In this video, we are going to be looking at matching the following distance versus time graphs to their corresponding velocity versus time graphs. In this video, I will not be giving you the answers, but walking you through some of the ideas of how to do these quickly. Let's look at this first one. This first one, we notice, has a negative slope, then not quite so negative slope, and then back to a quite negative slope. And these look about the same slope. The velocity versus time graph should, in this case, have a lot of three straight lines. And because they're negatives, they're gonna all be under the x-axis at negative straight lines. As we remember, curved lines will go diagonal, diagonal lines go straight, and straight lines will go along the x-axis. Since these are straight lines, they're going to go flat. So we should expect ones where it should be flat, not quite as flat, and then back to the same flatness, and making this nice plateau all underneath the x-axis. Now let's move over to the second one. We see a curve. We know that it should start off with a flat line. The velocity graph should be a flat line, diagonal line, then a flat line, then another diagonal. The third one will start off with diagonal, another diagonal, and then go to 0. This one should be 0, a flat line, and then 0 again. As you can see, these all have unique structures. Now let's talk about what they are actually doing. In this first one, we can see that the person is moving away from a far away position, going towards the origin in a certain amount of time. They're walking to the 0 point, or to us. Passing us, and then they pass us, and then they slow down, but they walk away from us, going backwards behind us, slowly, and then eventually speeds up. Here, they're starting at a position of far away again, but this time they are going at us and they're changing their speed. They're curving, that's acceleration. And they're speeding up towards us, coming up towards finally, and then they going down and down and down until they pass us. There's where they pass us, is the y-intercept. And then continue on this constant speed, then eventually slowing down until they get to a flat line where they would be considered stopped. Each one of these has a quite unique. I'll let you figure out the rest. And if you have any further questions, go ahead and ask your teacher.